Section 8.3 is graphing f of x equals ax squared plus bx plus c. So we're going to look at graphing quadratics in standard form. For your learning targets, you will be able to graph quadratic functions of the form f of x equals ax squared plus bx plus c, and you will be able to find the maximum and minimum values of a quadratic function. So looking at our core concepts, we're looking at the graph of a quadratic in standard form. And the first thing that we need to take note of is our a value. So our a value, if it's positive, then our parabola is going to open upward like this one that's shown. If it's negative, it's going to open downward. The next thing we need to look at is the c value. Our c value is going to be the y-intercept of the graph of our parabola. And then the x-coordinate of the vertex, as well as the axis of symmetry, comes from this formula here, which is x equals negative b over 2a. So when you calculate that, that's going to give you the x value of your vertex as well as this axis of symmetry line. So for example 1, we're finding the axis of symmetry and the vertex. So we have our equation here, f of x equals 2x squared minus 4x plus 5. So I'm going to go ahead and label these with my a, my b, and my c values. So again, that formula to find the axis of symmetry is x equals negative b over 2a. So we're going to plug in our a and our b values into this formula. So I have negative, and then I'm plugging in b, which is also negative. So this is going to become negative 4 over 2 times a, which is 2. So negative cancels, so this becomes positive 4 over 2 times 2 is 4. So this is going to simplify to x equals 1. So x equals 1 is our axis of symmetry. So for our vertex, our x value of our vertex is also 1. So now we need to plug in 1 into this equation here to find the y value of our vertex. So we have 2 times 1 squared minus 4 times 1 plus 5. So following PEMDAS, we simplify the exponents first. So 1 squared is going to give us 1. Then we do 2 times 1, which is 2. Negative 4 times 1 is negative 4, and bring down that plus 5. 2 minus 4 is negative 2, and then negative 2 plus 5 gives us 3. So the y value of our vertex is 3, and our vertex is at the point 1, 3. So now example 2 is looking at graphing. This is going to start the same way. We're going to start by finding the axis of symmetry and the vertex. So I'm going to go ahead and label my a, my b, and my c values, and start by calculating my axis of symmetry using that negative b over 2a formula. So when I plug in my values, I have negative 2 over 2 times, a is the number in front of x squared, so a is going to be 1. So negative becomes positive, so I have positive 2 over 2 times 1 is 2. So this gives us x equals 1. So this is my axis of symmetry. So I've drawn in a dashed yellow line at the axis of symmetry. So now we want to start by making our table of points. And this x value is also the x value of our vertex. So I'm going to put that in the middle of my table. Then I'm going to pick 2 numbers above and 2 numbers below. So I'm going to do 0 and negative 1, as well as 2 and 3. So first, let's plug in our 1 into this equation. So we're going to get 1 squared minus 2 times 1 minus 3. So 1 squared is 1. Then we jump down to multiplying. So -2 times 1 is -2. And then from left to right, 1 minus 2 is -1. -1 minus 3 gives us -4. So our vertex is at 1, -4. So now we're going to go ahead and calculate these other two values by plugging them into the same equation and doing the same work that we did for 1. You can also see that right here we have x is 0. So this is going to be our y-intercept. So our y-intercept here is going to be -3. And again, parabolas have symmetry, so we can mirror that across over here to our -2 value. And then again, when you plug in -1 or 3, you should get 0, and you can mirror that value across. So then we're going to plot our points and draw our parabola. Okay, so here's our graph of our parabola, and then last we need to state the domain and the range. So the domain, again, of all quadratic functions is going to be all real numbers. And then your range is based off of the y value of your vertex, which in this case is -4. And since our parabola is opening upward, our range is going to be greater than or equal to. Example 3 is finding a maximum or minimum value. If you have a maximum value, your parabola is going to be opening downward, and the maximum value comes from the y value of the vertex. And in this case, your a value is going to be negative because the parabola is opening downward. If you have a minimum value, your parabola is opening upward, and the minimum value comes from the y value of the vertex. And in this case, your a value is going to be positive. So for this problem, we need to tell whether the function has a minimum or a maximum and then find that value. So when we look at our a value here, we have +5. So if our a value is positive, that means that we're going to have a minimum. So now we need to calculate what that minimum value is, which is basically finding your vertex. So we're going to start by using that axis of symmetry formula because that also tells us the x value of our vertex. So we have -b/2a. So we're going to plug this information in. So I have -15/2 times 5. So we get -15/10. So -15/10 is going to simplify to -3/2 or -1.5. So now the -1.5, we need to plug into our original equation. So we have 5 times -1.5 squared plus 15 times -1.5 minus 10. So we're starting with the -1.5 squared, and that's going to become positive 2.25. .25 times 5 becomes 11.25. And 15 times -1.5 becomes -22.5. And then we bring down our minus 10. So then we have 11.25 minus 22.5, which is -11.25. 11.25 minus 10 is going to give us -21.25, which is our minimum answer.